Okay, moving on to scientific notation, we know the idea is we need like a significant digit first, followed by a decimal, followed by any other significant digits, times 10 to some power. So when we write really large numbers in scientific notation, we use positive exponents. When we write really small numbers in scientific, we use negative exponents. So let's take a look at part A, 14A. So I'm looking at 300,000, it looks like. So what I do is I look for the first significant digit and put a decimal point after it. So that'll be 3.0. Okay. Then we put the whole times 10. That's always there, the times 10 piece. Now, determining the number of steps, if we were to put our decimal point in the original problem there and then count 1, 2, 3, 4, 5, we would end up right there. So that means we have to go 10 to the 5th power. Okay, the next one, there's a lot of digits here, but the first significant digit is -9, so it's going to be -9.5 times 10 to the, let's do our counting, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9th power. Okay, this one's one of our small numbers with the decimal here, so we'll still find the first significant digit, which is after the 2, so 2.4 times 10 to the, now because this is a small number, it's going to be negative, and the reason is because we're going to the left. So that's 1, 2, 3, 4, 5, 6, 7 units to the left. So that's a -7. Okay, and then one more here. There's more significant digits in this one, so I'm going to write them out. 4.578 times 10 to the, alright, so from the 4, we go 1, 2, 3 places, so that's a -3. Alright, now we have to go the other way around, going from scientific notation into standard form. This one, same idea. We're still going to be counting and moving decimals around. So what I do is for the positive exponents, like the 8 here, I make some room on the left because I know I'm going to be doing some loops to the right, and I just count over. If it's 8, then it's 8 loops from the decimal. So 1, 2, 3, 4, 5, 6, 7, 8. And I play the fill in the gaps game here. We fill in the little empty slots. 1, 2, 3, 4, 5, 6. This is where my decimal point will now be. I'll do a quick visual check to figure out where to put commas after every 3 going from right to left. So one here and one here. My final answer, 236 million. That's with 6 zeros. Okay, this next one, as you notice here, that's going to be a negative exponent, so that's going to make my number small. So I'm going to make some room off to the right this time, because I know I'm going to be moving left. I go 1, 2, 3, 4, 5, 6. And I fill in my gaps. So it appears that we're going to have 5 zeros here. Final answer, 0.000000564. Okay, and lastly, oh no, there's 2 more. So the next one, 2.5 times 10 to the 0. You should know that anything to the 0 power is 1. So in this case, we're not moving the decimal point. It's simply going to be 2.5. Last one off to the right here, another negative exponent type thing. So make room off to the left. So put your numbers on the right first. Move over 4 places. 1, 2, 3, 4. Fill in the gaps. Rewrite your decimal point. Final answer, 0.000624.